Year 4 and welcome to today's maths lesson, which is all about properties of triangles. We're going to be looking at different types of triangles, including equilateral, isosceles and scalene, and looking at how we can solve some problems before you have a go on my maths. Types of triangles, and we're going to learn about those today. So let's look at the first one. What do you notice about this triangle? Yeah, it's green. That's right, well done. But also, every side is 5 centimetres long. So all the sides are the same length. Now, with a triangle where all the sides are the same length, we call it an equilateral triangle. Now, if we look at this triangle at the moment, we can see it's not an equilateral triangle because not all the sides are equal. In this triangle, we have 2 sides that are the same length. And the third side is a different length. So 2 sides are 4 and one side is 2. So this type of triangle is called an isosceles triangle. And then in the last triangle we have here, all the sides are different lengths. And this is called a scalene triangle. Different lengths of sides here. We've got the numbers 2, 3, 4 and 5. Can we make as many different triangles as we can? So we can do this in a table. So if we want to make an equilateral triangle, they could all be 2 long, let's say centimetres. So each side could be 2 centimetres long, or they could all be 3 centimetres long, or they could be all 4 centimetres long, and so on. We can also make isosceles triangles. So in this example, one length is 3 centimetres and the other 2 lengths are 2 centimetres. We can make another type of isosceles triangle where the 2 lengths are now 3 centimetres, if you look at the diagram. Or we could make a scalene triangle where we have centimetre sides of 2, 3 and 4. And you can actually make some other ones as well. So pause the video and see which other ones you can make that we've not all made now. Just jot it down on a piece of paper. 5 seconds to answer each one before I tell you the answer. You're going to have a selection of triangles. Can you tell me whether they are equilateral, isosceles or scalene? So have a look at the first triangle. Which one is it? Shout it out. Yeah, it's equilateral. Well done. Oops, let's look at the next one. Is it equilateral, isosceles or scalene? It's equilateral because all the sides are the same length. Here's another one. What about this triangle? Yeah, that's right, once again, it's equilateral. Well done. A bit trickier now. This is not equilateral, what do you think? Well done, it's isosceles. That's correct. 2 sides here are the same length with one different length. What about this one? Yeah, well done. It's isosceles. And now look at this one. All the sides are different. So this is a what? Yay, that's right. It's a scalene. What about this one? Correct, it's an equilateral. And this one. That's right. It's a scalene triangle. Well done. Now we have a design made from a regular pentagon, and if you look in the regular pentagon, it's been split up into lots of different triangles, you can see here. Now the outside edges are all the same length. That's what makes it regular, and that's why an equilateral triangle would be a regular shape, but a scalene or isosceles triangle would not. Here is a triangle inside the design. Now, what could we call this triangle? We could call it the pinky-purpley triangle, but we're going to be more mathematical than that. And we're going to call it triangle ABE, because that's the letters given to the corners of this triangle. Here's A, here's B, and here's E. Now, we could have called it AEB, or BAE, or BEA, or EAB, or EBA. Doesn't really matter, because the letters can go in any order. But we've called it that triangle because the letters are on the corners. So what type of triangle is it? Have a think. Look closely. Two sides are the same length and one is longer. So that means it is an isosceles triangle. Well done. Now let's look at our pentagon again. Now it says click to shade in the triangle ADE. So here's D, and here's E. So it must be this part and this part. A, D, E. That's right. Now what type of triangle is that? Now looking closely, I think that is a scalene triangle, because I think all the sides are, or in fact actually no. If this is a regular shape, regular pentagon, this is actually an isosceles triangle. So be careful, because it looks like it could be a scalene, but we know this is a regular pentagon, which means A to E and E to D are the same size. And this is obviously a longer side. So this is an isosceles triangle, so be careful. So we now need to look at impossible triangles. Some triangles are impossible to make. So it says, using only side lengths, which are whole numbers, can you make an equilateral triangle with a perimeter of 6? Now remember, 6 centimetres is the perimeter which goes all the way around the outside. The perimeter is the distance all the way around the outside. It does not mean that each side is 6 centimetres. It means all three sides add up to 6. So here it would be 2. 2, 4, 6. Can you make another triangle with a perimeter of 6? Try it. So get a piece of paper. Can you create a different type of triangle which has a perimeter of 6, not all 2s? So you could try 3, 2 and 1. Get a piece of paper and a pencil and a ruler and have a go at drawing a triangle. Pause the video and come back when you've done it. So you should have found it's not possible. If one side was 3, the other side would not reach far enough to make a triangle. The triangle would never be a closed shape, because this length here is not long enough. So there's a little rule. So in order to make an isosceles or a scalene triangle, the total of the two shorter sides of the triangle must be greater than the longest side of the triangle. So this side and this side must add up to a number bigger than this side. As we can see, 1 and 2 is 3, doesn't work. But if this side was 3 and this side was 1, that would be 4 centimetres. That would be bigger than this, so you would then be able to create an isosceles triangle or scalene triangle. So I hope you found the video useful. Remember, an equilateral triangle has all the sides the same length, and if you want to be really clever, you can talk about the angles as well. All the angles are the same as well. They'll all be 60 degrees, because all the angles in a triangle will always add up to 180. On a scalene triangle, all the sides are different lengths, and all the angles inside the triangle are different as well. And on an isosceles triangle, 2 of the sides are the same, and 2 of the angles are also the same. And all 3 angles, remember, will always add up to 180 degrees. So you should now have enough information to complete my maths homework lesson, which you can log into now. But if you're not sure, send me or Miss Patel a message on Class Dojos and we'll help you. Good luck and see you soon.